All right, so today we are starting chapter 3. So we're going to look at some quadratic functions and models. We're going to be using completing the square to write polynomials. So we did completing the square earlier this year to solve. Now we are going to be writing polynomials in vertex form. And then we're also going to find minimums and maximums, which is just finding your vertex. So this book called vertex form, standard form. And so you'll notice when we go over the first example, like it'll say write it in standard form, but we're going to write it so we can see the vertex. So vertex form is something that we should have seen before. We have an a value on the outside, the x minus h. Keep in mind we do the opposite. So when we pull out the vertex, it's h and then k. Okay, not the negative h. And when we have this is commonly what we call standard form, the ax squared plus bx plus c. And the value of a determines the way that the parabola opens. So if a is positive and it opens upward, that creates a minimum value. And if it's a negative, it opens downward, and that creates your maximum value. Okay, so we're going to be identifying whether we have minimums or maximums today. So that is how we will be using that part. Okay, so example 1 says a quadratic function is given. We need to express the function in standard form, except, JK, it's really vertex form. It is kind of strange how different books refer to different things, but the vertex form is the form where you can pick out the vertex just by looking at it, which is going to be this form. Okay, so, and guess what? It's going to be given to you in the form f of x equals the ax plus bx plus c. So they wouldn't just ask you to write it again. And then we are going to find its a minimum or maximum value, and we're going to identify if it is a minimum or a maximum. So for f of x is equal to x squared minus 8x plus 8. Our first path is going to be to use completing the square to balance this equation out. So when we do this, the first thing we want to do is group the x terms together on one side. And for part A, that's not going to matter a ton because it is already set up pretty nicely for you. But other times you might have to do some rearranging, which is why I want you to make sure you have those x terms together. Okay, then we are going to check that the a value is equal to 1, because you may remember that in order to use completing the square, your a value has to be 1. And if it is, then we can add the spaces to complete the square. And then do we remember how to fill in those spaces? You guys remember the formula? Yeah, b over 2 squared. Great. Now the only thing that's going to be different today is the last time we did this, we were doing the same thing to both sides. So we would add this to both sides, b over 2 squared. Today, we are also going to be using the opposite. Okay, so when you're balancing an equation on one side, whatever you add, you have to subtract. Okay. All right, so we are going to start by doing our grouping. Okay, so we have these two together. We're verifying that the a value is 1. If it is, then we are going to add the space to complete the square. okay? And you're going to have those two spaces. So what we're trying to do is we're trying to complete this square, okay? We can't complete the square with this because this is not a perfect square here. Okay, so we're going to fill this in with b over 2 squared. So b is negative 8. If I divide that by 2, I get negative 4. And then remember, I like to write it like that because it makes my next step a little easier. But you are adding 16. So we're working with one side of the equation. If I add 16, I'm going to have to subtract it here. So this is going to be the opposite. Okay, 16 and negative 16 are opposites. Because if you have opposites, it's like you're adding 0. If you're adding 0, you are not altering that equation. All right, and then from here, we're going to factor. So if you were to factor x squared minus 8x plus 16, it would factor into x minus 4 and x minus 4, which is x minus 4 squared. 8 plus negative 16 is negative 8. This is going to be your function in standard form. This is part 1. Okay, what questions do we have about that part of the process? Okay, then let's identify our maximum and our minimum. Sorry, this is slanted, so I have to split this. All right, when you are identifying the max and min, we are going to be writing this in what is called function form, in a function notation. Okay, so we are going to write in function notation. Okay, so whenever we write in function notation, we have f of x equals. Function notation for this is f of h is equal to k. So your function notation for the max and the min, this is going to be your vertex. Okay, so the vertex, which you can see from your equation, is positive 4, negative 8. This is your h and your k. Okay, remember that your h value is always the opposite of what you see here. Okay, so when we write out our final answer, we're just going to write f of 4, which is our h, equals our k value. And then we're going to identify whether it's a minimum or maximum. Okay, can anybody tell me why this one is a minimum? Yeah, what's your a value? Yeah. Okay, so you're going to identify if it's a minimum or a maximum. Okay, and then just keep in mind your vertex, this is always your h, this is always your k. Okay, and if a is positive, that's when we have the minimum. Okay, and when you're doing step 2, you can do this right from here. Okay, it's not like you have to show your work for that, but I want you to have something visible when you're using this to help you that this is your vertex, so we know to plug that in for h and k, and we can visually see why we have a minimum. Okay, so we start to associate those things together. All right, let's try part B. F of x is equal to negative 6x plus 1 plus 3x squared. Okay, so see if you can do the first step. Okay, so we're going to put this in standard form, and then we're going to group those x terms together. So remember, we need to check to make sure a is equal to 1. In this case, your a is 3, not 1. Okay, so since a does not equal 1, you're going to factor out the a term from the x terms. I guess I should say the a value, but it's too late. Okay, so because a is not equal to 1, you want to factor out that value of a, okay, from those x terms. Okay, so a is not 1, a is 3. So when you factor that out, you get x squared minus 2x. And then if you want to set up the blank from there, you can. Now this is going to be a little different, but the first step is the same. So since we factored those out, we can complete the square here. We can do half of the b value because now our a value is 1. If I do half of negative 2, I get negative 1, and then I square it. So negative 1 squared is a positive 1, but because you have this inside the parentheses, you are going to have to distribute. Okay, so when you're deciding what to add or subtract, because this is in the parentheses, you have to distribute the a value. So if I distribute 3 to positive 1, I'm going to get positive 3. Okay, so really what I added here, the value that I added is 3. So that means if I added a 3, I'm going to subtract the 3. Okay, so again, this has to be the opposite of the value that you added. Okay, so you are going to distribute that. Now the rest is very similar. This 3 is going to stay in front, and you're still going to factor this. So if I factor x squared minus 2x plus 1, that factors into x minus 1 squared. And then if I add 1 and negative 3, I get negative 2. This is going to be my function. Okay, so this is my answer for part 1. Okay, for part 2, we're going to say if it's a minimum or a maximum. So we always look at this a value. The a value is positive because this time it's 3. And we know it opens upward, which creates a minimum. So we can just write that it's a minimum. You'll commonly see it like this. It'll be minimum and then a colon and then f of something equals something. Can you guys fill in those blanks and we'll check it together? So give it a try even if you're nervous. If you want to just think about it in your head, that's okay too. Okay, f of, what do we plug in for the first one? 1. 1 is your x coordinate. Okay, and then f of 1 is equal to what? Negative 2. Great. Okay, so that's going to be your minimum value. All right, and then go ahead and see if you can start part C. All right, if you haven't already grouped those together and factored out a negative, I want you to double check that. So you do have to factor out the negative. So even if it's a -1, okay, we are still factoring that out. And then we're going to do half of b. And then see if you can say whether it's a minute or a half. Okay, so we're grouping. Anytime it's not a is 1, we take something out. It's going to change it to -2. Okay, so half of -2 is -1. -1 squared is +1. But again, we have to distribute. So when you distribute -1 to +1, you subtracted 1. If this is the opposite, what am I going to put here? Yeah, just a +1. Okay, so then when I factor, I keep that negative in front so that a value drops down, and it will be x minus 1 squared when I factor. And -1 plus 1 is 0, so this is your final answer. Okay, you don't have to write the +0. Okay, so my a value is -1. If it's a negative, we know it opens downward, and that creates a maximum. Okay, so your maximum value is f of your h is equal to your k. So the h value is the opposite of what you see. It's a 1, and then if there's nothing added on the outside, it's just a 0. Okay, so that is going to be your final answer for part 2. Okay, does some of this seem familiar? Where you're balancing the equation? Okay, for example 2, we're going to find the maximum or minimum value of the function. So we have f of t is equal to 100 minus 49t minus 7t squared. And then we're going to find the x-coordinate of the vertex. So see if you can remember what the b and the a are in that case. Okay, do you guys have questions about how to find the a value or the b value? So remember that in a standard form, you'd have f of x equals ax squared plus bx plus c. So the a value is always in front of x squared. The b value is always in front of x. Okay, this is just written in backwards form. So your a value is -7, your b value is -49. Okay, and we're gonna do this example without the calculator, and then we're going to do example 3 with the calculator. Okay, so when we do the opposite of b, it becomes +49 over 2 times -7. And if you want to reduce from here, you can. Okay, if you have 49 over -14, we know 7 goes into both. Okay, so it'll be -7 over 2. But if you recognize here, oh, 49 divided by -7 is -7, you can just jump to that step, and that's fine. Okay. And then if we're finding the max or min, we have the x value, now we need the y value. So we're going to substitute that in for x into our equation. And if you want, you can also write it in standard form. So you can think of it as f of x equals negative 7t squared minus 49t plus 100. In this case, the input is t, so really what we found was that t value. They use t a lot when you're doing an application with time. So I just want you to know it's still finding that first value of your vertex. So negative 7 times negative 7 over 2 squared minus 49 times negative 7 over 2 plus 100. Okay, so I'm going to give you a moment to do this. Just exercising those mental math skills will really help. Working with fractions, whole numbers, order of operations. Alright, so when you square a fraction, you square the numerator and you square the denominator, and whenever you square anything, it becomes positive. Okay, and then here, see how you have to multiply negative 7 times 49? Okay, you can either just do 49 times 7, and this would be the 6, 343, or you could do 50 times 7, which is what? 350, and then subtract 7. Yep, and you get 343. And that is a little easier. So negative 343 over 4, and then look, you're doing the same thing again, 49 times 7. So plus 343 over 2 plus 100. So if we're going to add these, we need a common denominator. What did we decide that was? 4. So times 2 times 2 times 4 times 4. Now, when you're doing this, if you're doing 343 times 2 and then subtracting 343, what do you get? 343, right? Because if you were just doubling it and then taking it away, and then I can just add that to 400. So 743 over 4. Okay, and then it says find the maximum or minimum value. Because your A value is negative, we know that it will be a maximum. Okay, and then we're going to write this the same way in function notation. So f of negative 7 over 2 is equal to 743 over 4. And you could write that as a mixed number, but you don't have to, and it is preferred as an improper fraction. If you didn't have your calculator, writing it as a mixed number would just be an extra step for you. All right, now based on that, I want you guys to try this. After dealing with those numbers, this one should seem easier. Okay, so you're going to find the maximum or minimum, label that value. And then when we do example 3 together, I am going to put up that book and you want to get it out, you can, but you don't have to. All right, let's keep pounding. So when you are doing the opposite of b, you get -2 over 2 times a half. So -2 divided by 1 is -2. And then you are just going to plug that value into your h of x. So 1/2 -2 squared plus 2 times -2 minus 6. Following the order of operations, we will square the -2. Okay, and then 4 times a half is 2. Okay, so we have 2 minus 10, which will give you -8. So we're going to write the minimum as f of -2 equals -8. Oh, yeah, you could. You could. In fact, I feel like you should, right? If it's h of that. If you put f, that's okay too. Because it's the h of value. And then remember, the minimum is decided by a. So if a is positive, that's how you know whether you have that minimum. All right, now example 3 is from your textbook. So I wanted to model for you how you can make what you are doing visible when there's a story problem. Okay, if you're doing your homework and you get stuck on something, okay, and maybe some of these suggestions will also help you get unstuck. We have a very timely example because it's about apple trees. And what a fun fall activity to go apple picking. You guys ever do that? I don't think I have. I usually go to the cornfield. All right, so the number of apples produced by each tree in an apple orchard depends on how densely the trees are planted. If n trees are planted on an acre of land, then each tree produces 900 minus 9n apples. So the number of apples produced per acre is, and they give you this equation, a of n equals n times the quantity 900 minus 9n. Now, if you were to simplify that, you would have 900n minus 9n squared. So that's going to be a quadratic. So we're still going to use the same things that we've been doing throughout this lesson. Okay, so it says how many trees should be planted per acre to obtain the maximum yield of apples? Oops, sorry. Here's the question. Here's the beautiful picture. Okay, so I always think the important thing, the first thing, is to identify what the question is asking you to do. So I feel like even if you're getting stuck, something we can all do is just identify the questions. What are they asking? So they want to know how many trees, so I want you to write this down with me. How many trees should be planted per acre to yield the maximum amount of apples? So sometimes even just isolating that question, okay, can get rid of some of that extra stuff and we can focus on what we have to find. So we're trying to find how many trees we should plant, and then this per acre is just a description, okay, to yield the maximum amount. anytime they ask you for a maximum or a minimum, keep in mind that that's the vertex. And so you can find the vertex of your equation. Okay, what's something else that they gave us in that problem that we should probably write down? Yeah, the equation. So they gave that to us, that a of n was equal to n times 900 minus 9n. Okay, what's important with the equation is that we understand what it means. So a lot of times in the story problem, they will tell you what it means. So if we just look above it, it says, so the number of apples produced per acre is, okay, so this is going to give you the number of apples produced per acre. Okay, that's what it's going to describe. And then from there, I want you to see if you can tell me what the input and the output are in this equation. Let's try to use some words and variables. Okay, so the input is what? What's your variable first? What's the input variable? What's that? N, okay? So if we look back, it says that the N value is the number of trees, okay? So N is going to be the trees. And that just so happens to be what they asked us to find. Sometimes they might ask you to find the output, okay? Your output is the A of N. And because it says that's the number of apples produced per acre, okay, that means it's the, yeah, sorry that that's not parallel, but I just drew the arrow. A of N is the number of apples, N is the number of trees. Okay, so we have to find N. Okay, and because it's the input, we can use x equals the opposite of b over 2a. Okay, so if you wanted to find it with algebra, you could just use this. I like algebra better than I like the graphs, so I would probably do that if it was a simple equation. If I had to find the output though, I would definitely use a graphing device. So you have options here. You can use your graphing calculator to find the vertex, which in your graphing calculator, you'd have to calculate the max or the min, or you can use Desmos. Okay, and then if you're using the graphing calculator or Desmos, you're going to have to adjust the window. Okay, or you can use algebra. So you can choose your own adventure. I will show you all of your adventures that can be had. Okay, so the first thing we could do is we could graph this. And to graph it, you don't even need to multiply. You would just do x times 900 minus 9x here. I'm in a different window. Okay, and here I wouldn't be able to see it. Okay, I can see the line here. It actually looks like it's going straight up. So sometimes when I'm adjusting the window, I use algebra anyway. I'm also going to show you how to do this on Desmos. Anytime you have to adjust a window pretty far, which is going to happen here, I recommend using Desmos to start. So if you are using algebra, you would just distribute to see your quadratic function. So 900n minus 9n squared. And then you could do the opposite of b over 2a. So the opposite of b is negative 900. Okay, and then like I said, this would be something where you could use your calculator. So we'll just divide, we get 50. Okay, and then that can help you too if like you had to find it on your calculator. You could adjust your window. I always double it, so I would like go out to 100 so I can see what that is. Okay, and then I might start with my max at 100 or 500. Okay, and I can see part of it, but I can't see that whole thing there. Okay, so all you had to find was your input. Your x value is n. So in this case, algebra would be faster than using your graphing calculator, but we'll still look at it with Desmos so we can see that. Okay, and then your answer is going to be 50 trees. Okay, and that's because you found on the parabola, which I'm just going to make a little parabola here. Okay, what you found was the x coordinate is 50, and then you are going to, I'm going to show you how you can also find the y coordinate, because this could have very easily asked you, like, what's the maximum number of apples produced per acre, and then we'd have to do that. So I would recommend doing this on Desmos. You could also just plug in 50 in here, and you'd be able to find that answer. Okay, so this would be 50 times 900 minus 9 times 50. Okay, and then see how it's a really large number. Okay, so again, it's faster to do it with algebra, but you could make this 30,000, go by hundreds. Oh, it's so beautiful. And then, of course, if you had Desmos, you would just click on the maximum, right? Okay, and you could scroll. And then if you want to use your graphing calculator, you just got to give it some bounds. So it says search in between those, tell me what the maximum is. Okay, the 49.99 is going to round to 50 there. All right, any questions for me on that last one?